Hi, I'm Andy Barnes. I'm the Commercial Director at Adaptix Ltd, and we're here today at the National Composites Centre to display our capability on robot arms.
So I've been working with Adaptix for a couple of years now on their CR&D projects. I've been the primary project manager, and here at the NCC we've been helping Adaptix to develop their NDT technology within the engineering, particularly aerospace sector.
We manufactured and supplied a number of aerospace type reference standards containing typical defects, which we ran through conventional NDT systems to show what the current state of detectability is, and for Adaptix to use to test out their technology on. We managed to get very similar results to what we'd get with conventional CT in a lot less time, without the constraints of space that you get with a standard CT scanner. And it was able to replicate some of the detection capabilities that we get with conventional ultrasonics as well.
The Adaptix NDT technology shows some key benefits over more traditional methods. So it has speed and potential cost benefits over the traditional X-ray CT, and at the same time, when competing with the traditional faster methods such as UT, ultrasonics, it can provide an improved fault detection. So you can see, get a clearer picture of the part. Radiography helps you see a more complete image, rather than ultrasonics is just giving you a reflection of what the emitter is seeing.
Compared to the CT that we use here, we're maybe a couple of hours per scan, and with the Adaptix we were talking 5 minutes maybe. From what we've seen of the Adaptix NDT system, it's certainly got some capabilities for composites. We've seen the benefits of it that could be deployed in both manufacture and in a maintenance environment. And as I mentioned, the flexibility and the ability to apply it is, in a portable situation, is a real benefit.
Yeah, so again, it's the way it combines certain strengths. So it's the idea of being fast and low cost, but also detailed. So the Adaptix technology provides both of those benefits with less of the drawbacks of traditional methods. So it's got a unique niche that it could fit within.
Yeah, one of the main methods that we use for inspecting composites in general is ultrasound, but that requires a cured composite because the ultrasound needs the resin matrix to support the propagation through the material. We're getting more and more interested in looking at preforms, uncured ply stacks, fibre stacks, to identify defects before the item's cured. Because the Adaptix system uses X-rays, it's not constrained by the same limitations that you have with ultrasound, and it's perfectly capable of inspecting dry fibre forms as well. The fact that the system's low powered means that it's eminently suitable for most of the composites, which only require relatively low power to get through. But it also means that the exclusion zone, if you're working in the same environment as other people, is quite small, which means you don't need to close down a whole hangar or a whole factory to allow the inspections to take place. I think there's a lot of promise in this technology. For a start, it's digital, which means that it lends itself to the whole industry 4, digital twin, all of that sort of stuff. And the fact that the output is digital lends itself to using AI for automated defect recognition. The flexibility and the portability of the equipment means that it can be used at inspection through the whole manufacturing life cycle, from the preform through to the cured part and through to the completed component in service.
I think one of the key things is going to be continuing to develop it and test it out against real-world aerospace and engineering components, because it's only by building up that experience and building up that evidence against real defects, real components, that you can demonstrate its capabilities. But I think, given that opportunity, I definitely think there's potential to take the technology into production. So again, we've seen some really interesting scans with the metallic additive components that have been scanned so far during this project. So it's really interesting to actually see what Adaptix's X-ray technology can do looking through a very unique and novel manufacturing method. You've been able to see some really interesting internals within the components. I think that one of the key things we need to look at is, for larger and more dense components, how do we balance that? How do we get the energy high enough to penetrate the components without wiping out, being able to see defects in the earlier parts of the components? But I think, again, novel NDT techniques combining with novel manufacturing techniques can really help push that manufacturing forward. Continuing to engage with the primes in the aerospace sector is of key importance.
If you can get some enthusiasm from one of the primes, then it's going to give a much better journey into getting it qualified. So continuing to develop the software, as mentioned earlier, talking about AI for automatic defect recognition to isolate and identify safety critical defects in parts. Obviously that needs to be developed in conjunction with the requirements from the end user and from the manufacturer. And today we're demonstrating the ability to mount the system onto robots, which means you can do an automated inspection, probably most suited to a manufacturing environment, because it's easy to bring the parts to a robot machine than it is to bring robots to a large aerospace component such as a wing or an aircraft.
We've been working with the National Composites Centre to verify our capability on an ATI grant, that's the Aerospace Technology Institute, and that is comparing our inspection capability, our digital tomosynthesis 3D X-ray, to how we look at benchmark coupons from various aerospace primes against ultrasound, CT, computed tomography, 3D X-ray, and that's how we've worked out and shown what our capability is.